Okay, looking at this question, we've got this curve, 2 ln bracket 8 minus x close bracket meets the line y equals x at a single point x equals a, and we can see that a is slightly before 4 and should be above 3 apparently. So if the curve y also beats the line y equals x, then we can say that x meets the line 2 ln 8 minus x, but I think it'd be much better to write that as a new function, which we call it g of x is equal to 2 ln 8 minus x take away x. The reason I've done that is because the reason I put the x on the right hand side is because if I should put in the value 3 and 4, if I get a change in sign for the output, then I know that I've gone past this as a solution, and I know that because I've created a continuous function. What I mean by that is, if I was to draw the line 2 ln minus x, my pen wouldn't come off the paper. It would be a continuous function. So what I'm going to do is I'm going to evaluate g of 3 and g of 4 on my calculator right now. You should do the same, okay, and put down the values. So here we go. 2 ln 8 take away 3 is 5. Take away 3, I get a value of positive 0.2189. That'll do. And if I try the same thing for g of 4, I get 2 ln 4 minus 4. I get a negative value, minus 1.2274. So what I'm going to say is, since g of x is a continuous function and I can see that there's a change in polarity, change in sign between plus and minus, I can conclude that there is indeed a solution between the values of 3 and 4. Okay, so that's the first part. So the curve with the equation blah 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 meets the line where x equals a, and I can indeed conclude that alpha is in between 4 and 3, as g of x is a continuous function. That's important we say that. And there is a change in sign between 3 and 4. Okay, x n minus n plus 1, I'll write it here for you. X n plus 1 is equal to 2 ln 8 minus xn. In other words, if he wants to improve upon his initial guess for the solution, he needs to take his initial guess away from 8, find the natural logarithm of that number and times it by 2, and that becomes his next x value for approximation. Okay, so if it's okay with you, I'm going to scroll down now to the next part of the question. Hopefully you can see that yes, he's going to try and use his first guess is x1 is equal to 4. Okay, so his next guess, x2, is going to be 2 times 8, take away his previous guess, okay, and that's going to be his next guess. Okay, well, let's find out if that works, shall we? Okay, so what we're going to do first of all is I'm interested to see, does this iteration, does it diverge, each guess get bigger and bigger, or does it converge in a value? But then what we're going to do is look at the actual graph that we've been given. because we could use that sort of system of cobwebs and spiral staircases, etc., to see whether we should approach a solution. So we're going to look at this two different ways, I think, for the 2 marks. So evaluating 2 Lun 4, I get 2.77. That's become my answer now. So I'm going to type into my calculator 2 Lun 8 minus answer, close bracket. Then I can just keep pressing the equals button to get to my next value. It goes to 3.3. 3x4 goes to 3.09, and you can see if you keep pressing the equals button, it is indeed converging on a value. It looks to me like when you get to about down to x to about the 10 or something, it looks like it's going to 3.16. But that's not going to be good enough to get both of those marks. It does say in the question using the graph, and I haven't done that so far. I've used the student's iteration. So what I'm going to do is I'm going to go back to the graph, and I'm going to see what's going to happen as we put x equals 4 into that graph. So when you put in x equals 4, the calculator will give you that y value here, whatever it is, and that is going to become our new x value, which means that since this is the line y equals x is here, that means that my new x guess is going to be this value here. If I now input that value, that's my new, that's x2. If I now put x2 into the graph function, it's going to give me this value here. And if I, now that's my new y value, but if I make it hit the line y equals x, I'm going to get my x3 value, which I put into the graph. It's going to hit the graph, I think so on and so forth. You can see that this is cobwebbing. It's a cobweb, isn't it? It's spiraling in on the intersection. Therefore, it's going to give me a solution. And that's really what you need to explain to the examiner. I would draw a graph on this graph to show that you've used the graph. Okay.